Okay, so today we have 3 items in the agenda. First one, we will briefly cover the new security features in Istio release 1.1. Li Min and I both will talk about those features. And after that, Li Min will talk about the follow-ups under API key authentication. And the last item, I will follow up on the CLL pluggability design. So let's go to the first item. Let me present. All right, let me make this bigger. Yeah. So in 1.1, it's a pretty big change in terms of everything in Istio. We shipped a lot of features. So in terms of security, I can cover several points here, and then Li Min will cover the rest of them. So for the first one, we in 1.1 we have the readiness and the liveness probes support for the Kubernetes HTTP protocol. Even when the mutual TLS is enabled, if you go to this release notes, let me show you. So we have 4 ways to actually do this houseness probe with mutual TLS enabled. I think one of the ways that we recently support is they're using the pilot agent to proxy their non-mutual TLS traffic, to proxy the non-mutual TLS traffic to their to your workload. And there are also some other modes as well. I won't discuss them in details here. And the third one is identity provisioning through SDS. This one introduces, now it's an opt-in feature, which means by default, when you are turning on the mutual TLS, it's still using the legacy secret file mount approach, volume mount approach. But there's a way for you to use the SDS, and what that will do is it will bring up the daemon sets, which are the CLL agents on each node, and those CLL agents will basically act as the SDS server for all the workloads on the same node, and then request the certificates for those nodes, for those pods, by talking to Citadel through their CSR. And if you want to see more about that, you can click into this link. We have a task for that. For the last 3 items, I can also cover them. External certificate management in Ingress Gateway Controller. This one is a big improvement to our previous solution, which means in our previous solution, your external certificates are file mounted to those gateway controllers, ingress gateway controllers. That has a problem. Whenever you update your gateway to include more certificates, you will have to deploy the controller with a new configuration, and then your controller has to be restarted. That's really annoying for our users. So our improvement on that is to introduce a SDS server onto their controller pod. So that server the SDS server will be basically a Citadel agent. It's very similar to the Citadel agent. It's sitting as a sidecar on the same pod as their ingress gateway controller. What that SDS server does is it exposes the SDS service to their controller, and the controller can call that service to retrieve their external certificates and keys. And that sidecar, that SDS server now, it gets their external certificate by calling the API server to accessing their secrets. So the users can put those external certificate and keys into the secret, and then the SDS server can read that and deliver that to their ingress gateway controller. If you want to integrate this with their cert manager, you can ask the cert manager to put those generated keys and certs to the secret, and then the SDS server on their controller can read that directly. The second to the last one is Vault PKI integration. If you want to see more about this, you can click into this link. And the last one is the customized trust domains. This one will be enabled. It's opt-in feature as well. We don't have a task here yet. We are writing it to tell the users how to customize their trust domains. By default, it's a cluster.local, but we can tune their Helm parameter, Helm flags to configure a different one. So those are all about what I can cover. And Li Min will.
Do you have documentation for the last one?
I will write one. Yes. So Li Min, you can talk about other items.
Okay. Thanks, Oliver. So for authorization part, so the first I want to mention we have a change on the ABAC configuration. So previously we have the ABAC config which enables the Istio authorization, and later we realized it has the wrong scope. It's a namespace scope, but it should be cluster scope. So we replaced the original ABAC config with the cluster ABAC config resource. And we also provide a script so that you can migrate from the existing ABAC config to a cluster ABAC config. And in the meanwhile, we still support the old config. So if you have ABAC config currently is in use, it won't break. So our code is still supporting the old config. For the features, I want to highlight two features for authorization. So the first one is previously Istio authorization support only HTTP and gRPC service. And in release 1.1, we added support for TCP services. So now you can do authorization for TCP services. I think that's a big plus. The second one is authorization for end user groups. So with this support, you can define authorization policy that assign some roles to a group. For example, you can assign a certain role to admin group. Then in your JOS token, you can have the groups claim, which says which identify the coming request for the user belongs to the admin group. You can do the same for other claims. So, for example, you can assign a role to a person that belongs to HR org, for example, and then in your JOS claim you can add that property saying this specifying this person belongs to orgs HR or other box. We do have documentation for both features, so you can try it out just following the task. Yeah, I think that's it.
The author, you covered all of them?
Right.
Okay, sounds good. Do you have any questions from the community? Anyone? Okay. Then let's go to the next item. Do you want to present?
Yeah.
Sure.
Okay. Yeah. Okay. So this presentation is mostly follow up on the previous presentation Scott had. On that review, we had a lot of questions regarding the relationship between RC token, OS token, and the API key. And so the first part of my presentation is on basically explain the relationship between these credentials. And the second part, I'm going to talk about the authentication policy change to incorporate these new credential types. So RC token. We have already talked about RC token. So RC token is a special token that's used inside the Istio mesh. We want to introduce RC token as a special credential type because for the following reasons. So first, it makes a clear distinction between internal token and the external token. We want to call out that RC token is an internal token. It's different from any other external credential like JOT or other opaque token. Second, so we want to have RC token definition in one place globally, and all the workload inside the mesh can directly refer to it. They don't have to define. We don't have to define the RC token spec for every workload. So although RC token is just a JOS token, but for better user experience, we want to define it globally once and refer it in all the other places. And lastly, the process of RC token is different from the ordinary JOS token. The validation part is the same. However, when we extract the token payload, for RC token, we extract from the original claim instead of the normal JOS claim. So that's one difference. Yeah, there can be other difference. That's just one thing I want to call out. OS token and API key. These two credentials are actually very similar. So they are both opaque tokens. So they have to be sent to a token server in order to validate it. And in this sense, you can think of API key as a special type of opaque OS token. Although API key has its own property and normally used to identify the APIs that the caller is granted access to, but this distinguishing is this difference is minor. So we want to just treat API key as another type of opaque token. So normally, so for opaque token, there is a standard called a token introspect. So if we follow the standard, there is a standard way calling the OAuth token introspect endpoint. So you have to use the introspect path, and the request have to carry the token, and the optional can also carry the token hint, token type hint. And the response can be either in a JSON format or it can be a JOS token. So both are supported by the standard. Okay, so in the case that the opaque token server actually returns a JOS token, it is very similar to the token exchange that RC token does. So in that case, so sometimes you can actually combine your opaque OAuth token server with the RC token server. So basically you can have a single token service which serve as both RC token server and the OAuth token server. So this picture just shows an example. You can send all the credentials, including JOS token, OAuth token, API key, to the token server. Then after token server does all the validation, it will return an RC token.
How does the token server know whether it should validate the OAuth token and just return a response to that, or whether it needs to include an RC token?
The token server logic is defined by itself. Do you mean, do we want to have some? So basically, we don't have.
OAuth is a relatively well-defined protocol, right? And we're saying we're going to support validating OAuth tokens. So
Right.
presumably, if we're validating OAuth tokens, we're talking this OAuth protocol, right? But you're saying that there's this token service that then knows that instead it's going to return an RC token. Is that?
Yeah. So basically, you have choice. Your token service can just validate OAuth token. You can also use the same token service serve as the RC token service. So in that case, it needs to follow the RC token interface, which we define in another doc.
Okay, so if you are calling the RC token API, you can just pass the OAuth. So how does the Istio Ingress gateway know whether it should use OAuth or whether it should use RC token when it makes this call? Like which API it should be talking?
Yeah, so that's in the policy setting.
Okay,
so,
cool. Well, if we're going to get to that later, then
yeah, I will show you example.
Okay, cool.
Yeah. Yes. So I should. So this is another picture. So basically, I'm showing. You can have some alternative architecture. So for example, you have an API key verification server, which is a legacy server. It won't return the RC token. It simply returns the claim in JSON format. And then, but you can have another token service which calls the API key verification server. So it just shows it can be separate server instead of a single server. Yeah, so now I'm going to talk about the authentication policy change in order to support all these credentials. We want to introduce a new CRD type called the Authentication Methods. Yeah, so just some precaution. This authentication policy change, we already had an internal discussion, but still there are some names or some minor details not settled down. So I hope it will just give you a rough idea how it looks like, but it's not finalized every detail. Yeah, so the authentication methods include JOS type and another server type. So you can do JWT authentication, which is done locally, or you can do server authentication, which is calling out to another remote server. RC token is a special type of JWT, and we also have a special type of RC token server specification. Yeah, sorry. It's just the special name. RC token is a special name, reserved name, but the specification is the same. Yeah, so the authentication method configuration is a mesh level singleton. You can define it for the whole mesh and then use it in all other places. So for the JWT spec, Istio already supports JWTs. So the JWT spec is actually the same as what we have today. You can define the issuer, the expected audience, the public URL, and the headers. Where do you extract the JWT token? And yeah, as I mentioned, we want to make RC token as a reserved type because it's a special in-mesh token. And for the server type, it contains the following fields. So it has a URL. Excuse me. So the URL specifies how to access the token server. So the example here is you can call this introspect URL in order to access this token service. And then you can define the secret name and the secret type. So you can put the credential how to access the token service in a Kubernetes secret, for example, or you can put it in a path, local path, and yeah, then you can use the credential to access the server. Excuse me. So this part basically specifies the URL, secret name, secret type, specifies how you access this token server. And there are other parts. We can specify the input header, basically specifies how you extract the credential, extract the token from. So yes, so for example, the API key, you can specify which header this API key locates. And it can also be extracted from query parameter. So we also have the input parameter. And you can also specify the token hint. So the token hint is used when we send the request to the token server, to the introspect token server. Sorry. And the output, you can also specify the output header. Basically, after you get a response, which header you want to push the token in. And RC token is a reserved token server name. It can be used to specify how to access the RC token. So after you define these authentication methods globally, then in the current authentication policy, you can just refer to it. So for example, for every sidecar, you can just say, accept a RC token. Just use a single line to specify it. And we are also thinking of supporting combination of credentials. So for example, you can say require both JWT token credential and the API key and the API key server validation.
Why is this a comma separated string instead of just a YAML list?
So normally, if you have a YAML list, then it's considered an OR relationship.
And this is saying that it's an AND relationship?
Yeah, so this is, the logic here is AND. So it requires both, basically.
Okay, I think that's not going to be very clear to people using this API. If we're going to do AND and OR semantics here, I think we need a clearer way to communicate that.
Right. Currently, we already have the OR semantics, right? We say the origin can be Google issued JOT or can be Facebook issued JOT. Basically, this is OR.
Yeah, I think we have to change the syntax to have the expression for AND explicitly.
Yeah, that's another option. Yeah, and this part maybe some kind of future work. I'm not sure how strong the requirement is to support AND. Basically requiring 2 credentials.
Yeah, just to understand correctly, so you say this use case you require the ingress authenticate job.
Yes.
As well as sending a remote request for the API key to.
Right.
I think one problem with requiring an AND is that what do you do with conflicting claims?
Can you give an example of a conflicting?
Well, the claims from 2 different sources end up we only have one name in the claims. So
I see.
Yeah, I'm not sure.
So that's possible. Yeah. So in that case, we need some conflict resolution. Yeah. So if user choose to use that, then either they make sure the claims don't conflict, or if there is conflict, I don't know. Yeah, we need to come up with some resolution for that.
Yeah, it may be better to address this in a completely separate document.
Yeah, right. Yeah, as I mentioned, there are a lot of details need to be figured out. So it's just some rough idea I'm presenting here. Yeah, so let's look at some concrete examples. So the first example is we have the remote RC token server. And all the authentication is actually delegated to the remote RC token server. Yeah, so in that case, we define an authentication method. There's a JOT credential we define, which is called the RC token. And this definition is used in Sidecar. So all the Sidecar nodes, all Sidecar can say, I accept RC token, and they can just share this definition. Yeah, and we also have the server authentication method. So the name is still debatable. Yeah, we can call it server or can call it remote or delegate. So in the server definition, basically we define how to access this RC token server and how to where to put the RC token.
Doesn't the RC token API already express where the token?
Yeah, we have the default header. If you don't express it, then basically the ingress authorization is the default header. But
no, but the RC token, like the get token API itself, the message that comes back has like headers to add. Right. So doesn't the server response contain the information about where this token goes in a request?
So this output header is basically specifies how ingress passes to the downstream sidecar services. It's not where
do you really mean
get a
downstream,
response.
like in the Envoy sense?
Is that called downstream? Anyway, from ingress to the sidecars.
So downstream is the direction that responses go. Upstream is the direction that requests go.
Okay, so I use the wrong term. So basically, it's an ingress service propagating the RC token to mesh services.
Right. Yes. I thought that the API that we defined for RC token, the response that comes back from the server, already says what header that token should be in.
Yeah, maybe that's true. So I guess this one is optional. We can remove it if the
let me
API
take a note if this is actually covered in the API RC token API definition.
Okay.
But otherwise we can have it here. I am not very sure. So on sidecar. So this is authentication policy for ingress, defining ingress. So in ingress, we basically say delegate authentication to RC token. I think that's also your question, Spike, right? So basically, we can specify. So the policy basically will indicate that the authentication is not done locally on ingress. It's dedicated to another server. And server definition.
Maybe I'm either not understanding this example or the example doesn't really make sense. The RC token is used inside the mesh, so why would the ingress gateway be saying that it should accept RC tokens?
Ingress is not saying it's accept. Oh, maybe.
So then I'm not really understanding what we're saying here. Is this the credentials that we will accept, or is this the credentials that we are going to go and exchange? That's what I'm not really sure is being expressed here.
Yeah, let's. So there are two differences, right? So the next one is the sidecar authentication policy. So on the sidecar's authentication policy, we are saying the sidecar, the service accept RC token. So you are saying, so we are using JOT RC token. It's accepting the RC token JOT. But on ingress, it's different. On ingress, it's server RC token. So basically, it's calling to the RC token server. It's a different authentication method. So one is doing the local JOT validation, and this JOT is RC token. And the other one is, maybe.
I feel like we need to rework
delegate or something.
Yeah, rework how we describe this, because I think that's going to be confusing about whether you're accepting a token, whether you're trying to exchange a token. Because like for the RC token, that's a token exchange, and so
So there are different ways to authenticate. So one way is to do the local authentication, which is the JOT validation.
Right.
And this is what the sidecar is doing here.
Yeah.
See. And the other way is to do the remote, or we call delegate authentication. Basically, we call to another server, which does the authentication. And then we just basically trust the remote server to do the authentication. And in this case, in the ingress case, it's doing the delegation.
Okay. Yeah, I like delegate better than server.
Okay. Maybe the name matters.
Just to go back a second to that output header, while that may not matter for an RC token server, if you're not doing an RC token server and you're just evaluating the OAuth and doing the introspection, you may want to go ahead and say what the output header would be so that it can be passed upstream to the sidecars.
And what would be put in that in that header? Is it like the claims?
Well, you can request a jot.
Okay.
I think in the case of if you're requesting claims, I don't think it's valid because I don't think you could trust that.
Yeah. Let's look at the second use case. So in the second use case, we are not doing the remote RC token server. Everything is done locally in Ingress. So the authentication method defines. So one is the JAWS authentication. It's Google JAWS authentication. Basically, accept Google issued JAWS. And for the server authentication, it defines the API key authentication. And for RC token, it's local. Basically, on Ingress, we are doing the local token exchange. So in this case, on Ingress.
Wait, this is the mesh-wide method?
Yeah. So this is authentication method is mesh-wide.
Right, but the RC token won't be local to every member of the mesh, right?
So this is just a definition. So we have the mesh-wide definition.
Right, but the mesh-wide definition is saying that we're not actually saying where the RC token server is. So how would a sidecar, for example, or like how would something else that needed to access the RC token remotely know where to go?
There is only one RC token server. That's the Ingress gateway. So basically, in this case, Ingress gateway and the RC token server is a combined server.
Right, and we're saying that in this configuration, there is no remote access to an RC token server for anybody in the mesh. Anybody who ever needs to use an RC token will already have the server local.
Everybody who needs to use the RC token.
Or sorry, everybody who
does the same thing.
Who does the token exchange.
Oh no. Token exchange is only at Ingress. So on Ingress, you are saying if you specify the maybe if you like delegate better. So basically it says this RC token server, we need to do a token exchange. And the RC token server is defined in the global authentication method, CID.
Right, but my question is like, is it realistic to expect that every member of the mesh that needs to do a token exchange will always have a local token server?
No, the local token server is only on Ingress.
So that means
right.
So the mesh level is just a definition. So the Ingress.
We're saying, okay, we have this configuration that's mesh wide, and the mesh wide configuration is saying nothing about where that server is reachable from, right? Like if you scroll up, the mesh wide configuration.
Yeah.
RC token has an empty map, right? So we're not specifying any information about the RC token server other than it exists.
Right.
So is that realistic? Is that like basically like is it right to have this global piece of configuration that says, oh, if you ever need to exchange tokens, you just look locally? Or will we be in a situation where some things that need to exchange tokens have a local instance of the token server, but other things that need to exchange tokens will have to talk to a remote server?
So exchange token will only happen in one place. There is a
depends on what you mean by one place, right? Like if I have ingress and I have a ton of traffic, maybe I have to like distribute that. Does that mean that I'm required to also distribute the token server? Like if I get too much traffic that a single instance of my ingress envoy can handle, and I want to have multiple ingress envoys, does that mean every single one of them needs to be running a token service?
Yeah,
and
actually,
is it? Are we saying that in the design of RC tokens, the only thing that will ever talk to the RC token to exchange is the ingress gateway? Nothing else is allowed to exchange tokens?
Yeah, I believe the current thought is RC token exchange only happens on ingress gateway.
But there's no constraint on the RC token design to limit that. I mean, it's more reasonable to do that. Right?
Yeah, I'm just sort of nervous about this idea of like mesh configuration that says that the location of this service is local.
Yeah, I feel this is a good discussion.
Actually,
can we take this offline and maybe
so
comment on their documents? If we need to discuss later, next time we can also bring this up in the next meeting. Because we have another item to discuss today. So is that sounds
actually I'm almost done. Yeah. So this is the last example. Maybe I just came up with the example right before the meeting. Maybe that's not a good idea to just have the local RC token, local token exchange example. But let's assume just follow up the first example. The second one I still need to figure it out.
Do you have anything else?
Yeah, and also please let us know your thought is.
Yeah.
Yeah, thanks.
Cool. So let's move on to the next one. Okay, please leave the comments to the document, and then we can keep it going and resolve all their concerns. So next one, I will follow up on the CLL pluggability design. This one will be mostly focusing on this because I get a lot of comments on the CSR API. And this is also what the community care about. And also the next one will be the CA rotation. I think this is also a good topic to talk about. I added a little bit new content here to explain what those every field means. This is our current API between the CLL and the CLL agent. And for the users, they want to extend, they want to use their custom CA and hook it up with their CLL agent. One of the choices is to follow this API standard. So I will briefly talk about every field and why we have them. So the Istio certificate request is the request sent from the CLL agent to the CA, right? And the response is the response from the CA to the CLL agent, right? It's fairly simple. And the service is the CA service. And the CSR in the request means it's a regular CSR. It has the public key in it. So the CA can refer to that public key so the user can refer to that public key to issue the certificate. It also has a signature in it so that the CA is able to verify the possession of this private key corresponding to the public key. Those are the two most important fields must be used by the CA, and other fields the CA can choose to ignore them or override them. we don't have any, we don't list what the CA needs to do on those other fields in this doc. The subject ID here, someone may find it a little bit confusing. The subject ID is the ID that the requester wants the CA to issue in their certificate if it is different from the identity presented in the credential, right? So in other words, by default, your identity in the issued certificate should come from the credential that is sent from the requester.
Sorry, what credential?
The credential can be, the credential can be any credential that is recognized by the CA. It could be in Kubernetes, for example. It is the Kubernetes service account jot.
Right, but that credential is not on this request. So where is it? Where is that credential
in the side
coming?
channel of the it is in the side channel of the gRPC request.
Okay.
Yeah. Thanks for bringing that point out. So by default, that will come from the credential, derived from the credential. Of course, their identity in the certificate should be in specific format. So we do a format conversion on the CA side. But if that identity you want is different from the identity provided by the credential, you can specify that in the subject ID.
This ID and this ID can also be present in the CSR itself, right?
That's a good point, right? It could be in the CSR itself, but I found out there's a problem because CSR, you have to have identity in it. Otherwise, it's not valid. And it doesn't give you a way to optionally say, I don't want to use this identity in the CSR. So what we propose here is we want have a separate field to explicitly call out the identity that you want if you want. Justin, if you are there, you can comment on this as well.
Yeah, I think the original intention was that we would give the certificate authority the ability to craft the specific identity based on the authenticator used by the client to the CA, which is not described here in this proto. This subject ID field was a way to allow the requester to express a desire to get a certificate for a different subject ID, different from what it's authenticating with. I think in normal use, most use cases, this subject ID field would not be used. And to Evan's point, I think if I recall correctly, with the CSR, we knew that we needed a public key and a proof of possession of the key, and the CSR was a standard way of expressing that. We also wanted to balance not having to wanting to do as little ASN1 parsing as possible. And so therefore we opted not to use any of the additional fields in the CSR and to make them expressly provided here in this proto.
Do we want to
wait? Who are you trying to keep from having to parse ASN1?
Any of the well, in this case it'd be the CA.
I mean, doesn't the CA have to?
Well, it's not CAs that you're going to talk to are going to be ASN1. They're going to talk ASN1 anyway. That's going to be their native interface.
Right.
The idea and also things like the subject ID. What I didn't understand. So this is Nick, by the way. What I didn't understand about the subject ID is what the requester is generating the CSR. So it can choose to put a different ID in the CSR already. So that's not clear in the doc. Why the subject ID is needed.
Yeah, yes, I agree that it's not clear in the doc. The intention here is that by default, the expected usage here is that the subject ID field would be empty, and that the identity of the requester would come from the authenticator used when connecting with the CA.
So the identity that's in the CSR is typically just ignored?
Right.
Yes.
I think that we need to be extra clear about the contract here. Like, if the CSR, the purpose of the CSR is purely to transmit the public key and proof of possession of it, then we should communicate that it should not be expected that any other data provided in the CSR is going to make it into the final document.
Yeah, I think that's a good point.
So is it, one thing I wasn't clear of, are you looking to try and make it easy to bridge existing CAs? Because as it's currently defined, it's going to be quite hard because of these rules, which are probably going to go against the grain of a lot of the implemented CAs out there. Or is the idea just to allow newly developed CAs to be able to integrate?
The latter.
So if it's just newly developed CAs, I would, if I was you, strongly think about not using a traditional CSR then, because the value of it seems to just be you want to generate a signature over some data. There's simpler things and simpler formats that you could pick there.
But the point here is the private key is not sent to. So if this API is changed, you not using the traditional CSR, then because here in this scheme, the private key is never sent to CA.
That's true about CSR schemes in general.
Okay, so but yes, then with the new proposed API, how does this CSR is formatted?
I would suggest looking at something like a JSON web signature, because we're using JOTs everywhere already. JSON web signature would seem like something to look at, or there's various other signature schemes, because all you're doing is using that to prove possession. So that all it is a proof, and the fact you've defined it as a CSR, but you're ignoring all the values inside the CSR, it sort of feels like, well,
but are they serving the same purpose of proving the ownership of the public key, or?
I don't think there's a public key field in their GKS. Sorry, GW. What's that called? GWS. But if we modify it, might be serving that purpose. My concern is that's not a typical way for requesting certificates, right? Normally, we send out the CSR.
And I think what Nick's pointing out is that what's being proposed here is also not a normal way of requesting certificates. And
yes.
The feedback that I'm hearing is that the formulation that we have here is also a bit misleading and confusing to folks.
Yeah, I think especially for
that's exactly right. I think you just need to choose: are you going to use a standard CSR, or are you going to say no, we're not using standard CSR, because the data in it's not useful? Then we can choose to use another format, which is maybe more native to the tools that are likely to be interacting with the system. So it's just examples. Otherwise, we're going to have to be very, very clear about how each field is used, and probably go to a greater level of documentation than you would in maybe some other protocols.
I think that's terrific feedback. Thank you very much for that.
I'd like to just add as a data point here that the Spire project has also been talking quite heavily about moving in this direction, moving away from CSR processing and in favor of something that's much more simple, that is used primarily just to transmit the public key.
Cool. Has Spire fixed on an interface yet, or is it still?
We have not, and I think we have not. And I'd be happy to have that conversation and see if we can arrive at something suitable for both of us.
That'd be awesome.
So I think here, instead of sending the subject ID, maybe it can send some metadata, some vague metadata is up to the interpretation of the CA, because CA basically what is put into the certificate is determined by CA. Right. CA can ignore the subject, ignore everything, and based on its own policy. For example, based on the credential accompanied by on this CSR to determine what are the credential, identity put in the certificate. So here, instead of limiting it to subject, we can make it more generic, something called any, or struct any data, but it's basically up to the CA to decide.
I think
wait, what's the motivation between trying to add more flexibility in this message? I thought that Istio is going to build an agent, and it's going to talk this protocol. Like,
we won't build. Like,
are we expecting the operators, to customize that agent? If not, then like just leave the subject ID.
Yeah. We want to keep the minimum information here, and only keep like necessary information here. We don't want to make it too flexible, right? Is that?
Yes. Yeah. There's a danger of adding. The more flexibility you have, the more complexity you have, and the more surface area for attacks you have.
Yeah.
Real quick, so one of the comments on the doc was also asking about the validity duration field, and I just wanted to address that by acknowledging that the intention here was that it was to be a client hint about the requested duration, but ultimately it's up to the CA to determine the range or the defaults of the certificate expiry period.
Yeah, we've been working on, a couple of folks on this call have been working on an integration with Spire in this regard, and we ran into some problems with this validity duration because Spire will not allow client to specify TTL. We put whatever we think is appropriate or whatever's configured, and currently the agent relies upon the validity durations that it specified in order to know when to renew things, and so there's no examination of the actual validity period that was returned.
Interesting. Sorry, go on.
Yeah, for the validity period, for HashiCorp Vault, the practice is the CA has a policy of the TTL, and the requester can send a hint of the TTL. But if the requested TTL is larger than the CA's policy, then it will be reduced to the maximums allowed for CA. I think that's probably can be, followed here. For the TTL part, for the validity, basically the client can hint, but not the CA will decide what the TTL will be.
So I'll let Marcos or Max on this call keep me honest here, but it's my understanding that if the certificate returned is less than the validity duration that the agent requested, that you'll end up with an expired certificate because the agent won't request a new one in time.
Yes, that's right.
We just need to fix that in the Citadel agent.
Yeah. So should we open a bug issue on this, or how should we?
Yeah, we can open a bug for that. Thank you, guys. I think we are out of time. We have one more thing to discuss, but we'll put that into next meeting's agenda, which is the CA rotation. All right. Thank you.
Thanks,
Please comment, in the doc. All right. Bye-bye.
Thanks. Bye.
Bye.
All right. Saved conflicts. Oh, Taoli.